Welcome back my dear friends. This is the 24th lecture for the Total Quality Management course. I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we are discussing the control charts and how the change of the sample size from N1 to N2, which is from N old to N new, would give you different set of informations both for the X bar charts and the R bar charts. And if you remember very intuitively, I had mentioned, and that should also be available to all of you, that the X bar would not change, X double bar, which is the center line, would not change, but obviously the upper control and the lower control will change depending on whether the sample size is increasing or decreasing. But when you come to the range charts, so you will find out the mean value R bar would also change. Similarly, the upper control and the lower control would change. Later on the fag end of the 23rd lecture, I did mention that those ranges would also depend on the type of error or alpha and beta, which I mentioned about the consumer risk, producer risk, and also it will depend on what are the values of alpha, and I did draw the diagram. So, you can understand that as alpha or the coverage is as change, 1 minus alpha would be the coverage, as the coverage change, how the limits change. And for a value of alpha as 0.002, you saw that the z value was coming out to be in the right hand side. That means from your side, if you look at the z value on the positive side, it was plus 3.09, and for a value on the left hand side, which was in the negative values, because we are considering the central value or the mean value as 0 for the standard normal distribution, the value would be minus 3.09. So, with this I will continue and also try to discuss that how, I will just very briefly discuss that how these alpha and betas basically affect your the central lines of the upper control and the lower control. Now, the X and R charts, when mu and sigma are known. So, we know that if they are known, so till now we have considered they are not known, and hence we replace them with the characteristics from the sample. So, X double bar in the long run, as the more observations you take, it basically becomes exactly equal to the mu value. Similarly, should be the case for the standard deviation. The X bar charts, if mu and sigma are known, I should highlight this because this is very important to understand. So, in the initial cases we did discuss the mu, where I am hovering my pen. Let me check whether the color highlighted, yes, where I am hovering my pen, this mu and sigma were unknown, but now we are considering them to be, say for example, known. So, if they are known, so how would you do the calculations? So, in the X bar charts, the UCL is basically becomes mu plus minus. So, UCL and LCL, I am just repeating the same thing. So, the limits would be plus minus 3 sigma by n. Now, this is important to understand. So, I will spend some time here and I use the color black, and as required we will. Now, consider this is the central line, which is equal to mu. The upper control, lower control, we are mentioning this mu plus. This 3 value is dependent on the factor which was there. It may not be 3, it may be something else also. I will come to that. So, first let me lay emphasis. I will change the color in order to make it more explicit. So, we will lay emphasis on this, and later on we will consider the value of y3. So, let us basically lay attention on. Now, what is important to note is this. Now, the mu is, I am using blue color to make you understand that why this blue colored sigma by square root n are important. So, mu's best estimate when you have is actually the sample mean, right. Now, what we need to understand is that what is the overall variance when you are trying to utilize the sample mean. So, that variance would be x bar So, this would be the variance for the sample. So, if you are aware of basic statistics, the overall variance would be coming out with using some simple calculations would be coming out to be this. Now, this is the variance. Now, if it is the variance, obviously you have to find out the standard deviation. So, what you do, you take the square root, this becomes, so that is why. So, this calculation part I am just leaving it for the interested readers. He or she can basically study this. I am just highlighting it and bolding it. So, you will understand that how it can be used. So, this is x bar, understand I am trying to find out the variance of the sample mean with respect to its population expected value. So, that is why it becomes sigma by square root of n. So, larger the sample size, technically the variance of that particular sample should in the long run decrease. So, it should be intuitive, because more and more observations we are taking, actually the variance of the sample as such, because you are taking all of them. So, in between the sample we will consider the variance actually becomes 0 in the long run technically. Now, coming to the case y3. So, let me again change the color and make it a white pen. So, now if you consider so let me first erase it. So, it will be easier, I would have a lot of space. So, I will erase this, I will erase this. So, this I am sure you would have noted it down when you are doing the NPTEL MOOC course. Obviously, you can go back to the slides and understand that. So, I would try to use the color green. Yes. So, now consider the standard normal deviate. This is mu is 0 and variance or the standard deviation here is 1. Now, when I consider plus minus 1, I am covering about 67%. When I consider plus minus 2, I am covering about 97, 95. So, these are approximate value, you can check the table. When I am considering about plus minus 3, then that coverage overall is about 99. So, this value of minus 3 and plus 3 is what is being used for these calculations. So, minus p obviously would come from here. So, this will give you an idea. So, if I want to basically decrease the limits, so plus minus 2 sigma, so obviously the values of 3 would be replaced accordingly. If I want to basically make it plus minus 1 sigma, so the value of that coefficient 3 would be replaced accordingly. So, you have to be careful what is your overall level of confidence you are using. Now, remember one thing, you will in the 23rd lecture, the last slide which you considered, we did mention, I will change the color of the highlighter in order to make you understand. We did consider some alpha. So, this alpha if you consider, so I will use the highlighter of yellow color to make things simple. So, these values when I am trying to hover it, so actually the total coverage which you will have here would basically be 1 minus alpha. So, as 1 minus alpha changes depending on the value of alpha, the values of z alpha by 2 and obviously minus z alpha by 2 would change. So, if I am trying to cover about 99% of the area, so then the right value, which means this area onto the right and this area onto the left, would total sum up to about 1 minus 99, which would be 1%. So, 1% would be divided into 2 equal halves, which would be 0.5% onto the left, which is on this part where I am putting my finger, and about 0.5% on the right. So, once when I calculate it from the table, those values which will basically give me that information would be plus 3 onto the right and minus 3 onto the left. So, plus 3 minus 3 I am basically talking from the point of view of the diagram which I have drawn. So, this would be decently clear to you if you do a decent amount or understand the standard normal tables and the distributions how they look like. So, I remove it in order for you to write more informations if I need. So, this I am considering for the case when mu and sigma are known. So, for the x bar charts, the upper control limit is x plus a value of 3. 3 as you know is can be changed sigma by square root of n, and the lower control limit would be the minus value of 3 into sigma by square root of n. Now, defining 3 by square root of n as a, you will basically have the upper control limit and the lower control limit given as mu plus a sigma and mu minus a sigma. Now, if you go back to the initial part where we considered the tables where the n values or the sample sizes were given, based on that we decided on a, d, b. So, this would now make sense that why we are considering those values accordingly. So, the more the spread, less the spread, obviously you will find out corresponding z values, z suffix that alpha by 2. So, what that alpha would be dictated by what is your overall coverage or level of confidence which you need. So, similarly when you go to the R charts, so the upper control limit would be again coming to the fact it will be d2 into sigma is the central line, because sigma is now known, it need not be replaced with the value of R. So, it will be d2 sigma, and the upper and the lower control values depending on the case that the overall coverage is about 99 would be basically 3 into d. So, these d3 values would depend on the dispersions which you have based on the values of the total coverages which you have. But let me tell you beforehand, obviously we are considering that the distributions based on the fact of sigmas also we tend to consider the central limit theorem to be true, but actually the distributions of the sample variance would technically be in the long run, if you understand the basic statistics and go into the depth, would be chi-square distribution, which we would use that later, but not now. For the R charts, the upper control limit would be d2 sigma plus 3 d3 into sigma. So, this d1, d2, d3, a1, a2, b and all these things can be found out from the table. So, I am not going to go into details for that. Similarly, the lower control limit would be of equal length below the central line. So, it will be d2 sigma, which is the central line, minus the value of 3 d3 into sigma. So, this 3 again has the same concept which I had discussed just few minutes back when we are discussing the x bar charts. So, defining the constants at d1 and d2 according. So, these are the capital D1, D2 which are technically used for the tables. You can find out the upper control, the lower control and the central line for the R charts. So, now giving a decent background, I know the time was limited, I tried to give the detailed qualitative feel, but obviously I would request, urge and really want the students to read the book. That will give them a lot of idea about total quality management. But one thing, the book goes very slowly. I am referring to the book time and again because I found that to be a very interesting book. It goes very slowly, builds up the concept slowly, but is a huge amount of information there, huge amount of concepts can be cleared if you read that book slowly. So, interpreting the charts is the next stage of our concern. So, in interpreting the patterns of the charts, we must first determine whether or not the R chart is in control. So, obviously, if it is not control, there is some variability, because R is the range which gives us the information on the variability. You must eliminate assignable causes from the R charts first. Never attempt to basically interpret the X charts when the R charts, X bar charts when the R charts indicates an out of control, because what is important, if you remember, I did discuss that the X bar charts are in some way trying to give you some information about the movement of the sample means. So, the more number of sample means which you have in a sample, if n is increasing, it is basically tending to give you some average characteristics which would not give you much information about the variability. But when you come to the R charts, which basically gives you the variability of the dispersion per sample in each sample, because if you need to find out the difference between the maximum and the minimum, that will give you much better informations whether there is a amount of variability. So, that means the first set of informations which we want about the process, or how the mechanical process or the manufacturing process or whatever this charts are being used for, that information would be coming out from technically from the R charts. So, that is why it is mentioned, so never attempt to interpret the X bar charts if the R charts are out of control. So, first try to understand the R charts and then go into the next stage of trying to understand the X bar charts. So, typical patterns may be seen and interpreted accordingly from the charts. So, we will very briefly discuss some cyclic patterns and some patterns which are evident from the conglomeration of the information which we get from the X bar charts and the R charts. Now, cyclic patterns are basically some cyclicity as there is a cycle which is going on. Cycle means we see a pattern, and how this pattern of cyclicity can be studied. So, it says that such a pattern on the chart may result from systematic environment changes, like in the summers the temperatures was high, then the winters the temperatures were low. Again the cyclicity of the summer comes and the temperatures increases and decreases. So, obviously it will come repeat in a particular cycle. Or there is a operator fatigue. So, in the morning the operator is absolutely at peak of his performance, his or her performance, and in the evening or after lunch the performance of that particular person decreases. So, obviously that may happen each day. Or they may be regular rotation operators, like say for example in the first shift you use an operator who is very skilled, and the second shift you use an operator who is not that skilled. So, that, and if that pattern of labor utilization is same, so obviously that cyclicity of the pattern would be very evident from the process control charts. Or say for example in the morning you are using the same operators, but you are using two different machines. In the morning half you are using a bad machine, and that means old machine, I will not use the word bad, but in the second half, depending on whatever production planning which you have done, you are using a new machine. So, now obviously there would be a cyclicity of the patterns which would be coming out and very evident from the process control charts. Or fluctuation in the voltages are there. Say for example in the night when the operators are working, the load of the electricity is not much from the residential areas. So, obviously there would not be much fluctuation in the voltage, but in the morning if you are working, your machine, your factory is working, there is a huge amount of load which is coming out from the residential areas, because say for example you work in an area where people are using in the mornings the different type of cooking machines, some geysers are being utilized for heating up the water, the electrical ovens are being used, or say for example different mixies are being used. So, obviously there is a huge load on the electricity that would have an effect on the usage of electricity for the machines which you are trying to utilize to manufacturing the product. So, I am giving very simple examples which should make sense to you. Or say for example you are using water to as a coolant, or you are using water to manufacture something for cutting tool at high pressure, and consider in the morning the water pressure is low because all the residential areas are using the water, and in the night the pressure is low because the water usage by other parties are less. So, there can be some examples like this which I mentioned: electricity usage, water usage, and operator being changed, machine being changed. Even if the same operator is there, fatigue being there in the afternoon, fatigue not being there in the morning. Maybe the fatigue in the evening would be the highest level, because there the overall efficiency of the worker keeps decreasing as the total working pattern of the operator comes to an end on a 8-hour shift. So, R charts will sometimes reveal cycles because of maintenance schedules. Maintenance schedules may be, say, let's say for example the machine is not old, it is relatively new, but it needs a lot of maintenance. So, if the moment is maintained, all the different parts have been replaced, they have been oiled, they have been checked, then the variability would be much less. But as there is a wear and tear, depreciation, machine is being utilized day in and day out, so obviously there would be some change in the variability onto the higher side. As I mentioned, operator fatigue is there. Tool wear who can be one use, like in maintenance, when you check the machine, you change the tool, but as in tool wear and tear is there, obviously it will have a negative effect on the machinability of the products which are being utilized, and the efficiency may decrease of the tool, which would not give you the right product. So, if you see the patterns, they would be, I will try to basically use the red color. So, this cyclicity would be repeated depending on, say for example, this is day 1 from morning to evening, this is say for example day 2 from morning to evening. So, you see in the morning, due to some reason the upper control limit and the lower control limit, even if they are same, there is a cyclicity of how the readings are being done, and it will give you a lot of information about how the process capability is. There can be mixture of patterns. A mixture is indicated when the plotted points tend to fall near or slightly outside the control limit, and basically it repeats. There is a mix and match of different type of effects which comes out, or they fall slightly outside the control limit with relatively few points near the central line. So, there is dispersion, there is wayward movement of the points from the central line, but basically they are being cluttered in and around the upper control or the lower control, and gives you some signal that there is some different type of effects which can be considered as a mixture of different type of effects which are happening. A mixture pattern can also occur when output product from several sources such as parallel machines is fed into a common stream. So, there are different type of process are being done for a single product on different same type of machines. Some of them are old, some of them are new, some of them are being operated by a new worker, some of them are being operated by old worker. For some, the wear and tear of the machine due to some maintenance problem is there. For some of them, the maintenance problem is not there, because they are being maintained by the operator himself or herself on a regular basis. So, obviously, if those comes into the picture, you will see the mixture pattern would be repeating in such a way that you will find out that the effect of those assignable causes which can be controlled are slowly revealing their face through the charts, which can be either the X bar charts and the R charts. And you remember, again I am repeating, variability concept or trying to understand the variability of dispersion would be more important than trying to find out how the X bar chart behaves, because variability is an essence of production process, is an essence of any process which you take, because they are random. But if randomness basically exceeds a limit, it gives you some signal that there are some problems in the overall system for which corrective actions should be taken. They can be shift in the process level, that means due to some process capability being changed, or due to, say for example, the products are coming out much good because the raw materials input has changed, because you are trying to get some different vendor to get the raw materials, or if the coolant has been changed, because as you keep using the coolant, obviously there would be different types of factors which may be affecting the coolant. The temperature may be affecting the coolant, or say for example granule particles which or the residue particles when you do either grinding or some using the lathe machines, all these things enter the coolant, and you are not able to take those external particles from there. So, obviously the coolant effect onto the machinability may have a positive or a negative effect, whether the trend may be on the higher side, like they are moving towards the upper control limit, or they are moving towards the lower control limit. So, shifts may result from introduction of new workers, may change due to method change, may be due to the raw material change as I mentioned, or machines have been changed. So, a change in the inspection methods or standards can also apply, like say for example, a new inspection pattern or inspection idea has been used or utilized, or the inspector himself or herself has different concept of how he wants to take the readings, or rather than taking 9 o'clock in the morning, you are taking at say for example 9:15 in the morning. So, obviously those patterns would have an effect, and if we see the shift can either go on to the downward trend, whether positive or negative we will understand later on, or it can go into the upper trend. So, you have to basically understand in which direction is moving and what is the overall effect of this type of shift in the process level. There may be a trend also, that means continuous movement in one direction may be there. So, and this may basically give you some informations that there is a usual wear and tear of the machines, the tool being utilized very heavily, the coolant is heating up, or the machine is heating up, or the temperature is increasing as the summer is coming, or the temperature is decreasing as the winter is coming. So, there is I will continue reading the second bullet point, which means the causes of gradual wear and tear of these machines are there, which will basically give you there is a depreciation, there is a deterioration of the tool or some other critical process of the component. They may be, as I said, that operator fatigue may be there, seasonal influences like temperature, humidity would be there, and this would basically give you an information that in which trend the overall process is moving. Whether it is positive or negative, you have to understand it later on, but these patterns would give you that information that there is some change which is happening in the overall process control. There can be stratifications also. So, which means the tendency of the points to cluster artificially around the central line. So, incorrect calculation the control limits may be a problem. They may be sampling process collects one or more units from several different underlying distribution with each subgroups may be important, which means that say for example, due to some reason you were planning to take the observations at 9 o'clock, 10 of them, then again at 10 o'clock, 10 of them, 11 o'clock, 10 of them, and you should continue. But say for example, due to some of the reason at 9 o'clock you are not able to take the observations, what the operator may do, which is definitely not right, he or she would take about 20 observations from 10 o'clock in the morning and try to basically compensate for not taking the set of readings of 10 in 9 o'clock. So, obviously it may mean that due to some reason that the 10 o'clock pattern or the 10 o'clock workmanship or the 10 o'clock usage of the machine or the coolant or the temperature were definitely not right. So, obviously all the set of so called variability which could be controlled are in those 20 readings which you are taking at 10 o'clock in the morning. So, obviously that is not right, but that will come out in the stratifications, and if the overall reading or set of observations are very good. So, and obviously those set of readings 20 in number would be cluttered in and around the mean. If they are not, they would be dispersed. So, obviously that would give you a negative signal that there is something wrong. So, obviously you have to study it accordingly. So, if you see the graph here, again I am using the red color, the stratifications would be in and around the central values. Obviously they can be stratified in and around the upper values also, but that would be studied separately. So, this will give you then information that how the patterns or either cyclicity or stratification and so on and so forth would give you some information that how the process control and capabilities from the point of the charts are going on, and you can basically study them in a very simple manner and with a lot of good judgment and common sense. If you are aware of the whole process, pass very critical informations about where the process is going, in which direction, whether it is right or wrong. So, with this I will close this lecture and continue with the 25th lecture later on. Have a nice day. Thank you very much.